You've heard AM, you've heard FM. Now, tune into DM Radio, the world's longest running show about data. Each week, host Eric Kavanaugh interviews the brightest minds in the world of information management. Want to be on the show? Send an email to info@dmradio.biz. Now, here's your host, Eric Kavanaugh.
All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanaugh here. Excited to enter 2024, our first show of the year, and DM Radio turns 16 years old next month. So apparently it's going to get a driver's permit. We'll be able to drive around and meet all of you. I'm joking, of course, but it's been a wild ride. And I have to say, I knew 16 years ago that data was going to be huge. It was going to be really important for the business world. And I am shocked at how big it's become. Of course, now AI is the hot topic. Gen AI, thanks to ChatGPT, Google's Bard, of course, Anthropic. There are multiple companies in this space now. AI is white hot, but guess what? You know what AI needs? Data. And in fact, clean, governed, trusted data is the cornerstone of good AI success. We'll talk about that a bit today. And of course, Gen AI is the hot topic. Interactive AI is what we're going to be talking about today. We'll talk about Gen AI in a few weeks. We may talk a bit about it today on this show. But I can tell you that AI in this new iteration and in this new phase is going to absolutely transform business applications, how business applications run, what they do. I think a lot of these AI models are going to subsume whole segments of traditional enterprise software. Low-hanging fruit, certainly chatbots. That's one thing interactive AI is good for. Also, things like HR, basic questions for HR, customer service, things of this nature. These technologies are great. But down the road a little bit, I look to this as a huge transformation in the analytics space. And I think the big vision in my mind is that every company, every big company at least, or every forward-thinking company is going to have their own model. They're probably going to pick their poison, either OpenAI through Microsoft or Google's Gemini or Anthropic with Claude. They're going to pick their poison and they're going to start training their model, ideally using a vector database is typically how you do these things, but you can actually embed it into the model itself. And they're going to build out their own models. Well, a couple of interesting things here before we bring our guests in, and we have two absolute rock star guests today. Sanjeev Mohan of SanjMo, former Gartner analyst, now on his own, doing tremendous work. And my good buddy Usama Fayyad, who has a cool new gig now. He is the inaugural executive director for the Institute for Experiential AI at Northeastern University. So we're going to talk about that and some of the secrets, the dirty little secrets, if you will, of making AI really work. Which, you know, the narrative, as I like to say, the narrative is always wrong. So the narrative in the media is that, oh, AI is going to take our jobs and it's bad. It's the red-eyed robot. And you can just flip it on and it's going to run your company. That is absolutely, positively not the case. AI really is going to require a lot of training, a lot of attention. But as I suggest, every big company is going to have their own model. They're going to work on that. And you got to be careful about training these models, you know, so you want embeddings of how you train them, anchors of truth, as someone called them. I love that concept. And you'll use this RAG model, which refers to retrieval augmented generation. And basically RAG, which came out of Facebook, is designed to ground or moor the content that comes out of a large language model. So you have to remember these large language models, they are predictive in nature. That's really all they are. They're systems of weightings. They've been trained on all this open text that's available on the interwebs. And their job is to predict what words you want based upon your prompt. So, you know, the old cliche, ask a stupid question, get a stupid answer. Well, load a stupid prompt, get a stupid return is what's going to happen with all that stuff. But be careful about training them. I often use this analogy of raising children. That's what you're doing with embeddings. All the significant memories you have in your life, whether at school or at work or other places, those are embeddings in your personal model, your real world AI-like model. So it's hard to untrain stuff. You got to be careful about that. So you don't want to get it off on the wrong foot. You want to get it off on the right foot. And that's going to be quality, trusted data, which means the data management stuff is really important, even more important than it was before. But with that fun opening, let me bring in Sanjeev Mohan of SanjMo. Sanjeev, these are crazy times we're in. I mean, this is a massive inflection point that is going to affect basically every corner of business. What are your thoughts about AI and where these things are going?
So I love how spontaneous this whole recording is, because I had no idea you would start with example of how a child learns. Because what AI is really trying to do is seriously mimic how humans learn stuff, how children learn. And actually, there's a lot of very interesting research and parallels between the human memory and LLMs. For example, in our brain, the back part of our brain is called the hippocampus. Hippocampus is actually there are a couple of other parts. Amygdala is another one. These these are the oldest parts of our human brain, and they store our long-term memories. They are like vector databases.
Hmm.
The youngest part of human brain is the front. It's called the prefrontal cortex. And the prefrontal cortex is where reasoning takes place. So it takes the memory that we have and it reasons in front of our head in prefrontal cortex. That part is like an LLM. So, why is it so important for humans to have a long, restful night of sleep? Is because all the experiences that we gather that get lodged into our hippocampus, the neural network then starts wiring them together. And so then next time we have a similar situation, we know how to react. And that happens by reasoning. Now, AI is not very good at reasoning at this point, but we are getting there. Other thing AI is not very good at is taking actions. So what is it good at? It's good at reading long documents. In fact, it's finding a lot of already a lot of adoption in contact centers, customer support, HR, because these departments have long documents. So if you can read those and you can start predicting the next token or the next word, then you can help the consumers. So I use AI all the time without even realizing. I've noticed how good Google Docs, email clients have become, where it's already predicting based on the
Mhm.
preceding words, it's predicting what I should write next. And so summarizing, translation, all those things are already being done very well. Of course, there's hallucination and all that we'll talk about, but that is the state of AI. We are trying to mimic the way humans learn and copy that in the world of AI.
Yeah, and that was the whole point of neural networks way back when. I mean, I've been studying these things for quite a long time, but the amount of progress that's been made in the last few years really is staggering. And it's
Yeah.
partly due to the transformer models. And Jürgen Schmidhuber, I've had a thread going with him back and forth. He wrote those papers, and what's funny is he wrote them like in the 1990s or something. So it goes to show you that it took a long time for the compute power and the architectures of computers to meet this demand. And of course, GPUs, and we'll talk a bit later about the CPUs, but it took a long time for us to get here. But now here we are, and it's obvious that this is going to shake the foundations of enterprise computing, right, Sanjeev?
Yeah, so thanks for bringing this up. I think the fact that technology advanced to a point where we could do some of these things now, right, they made it possible. In 1990s, there were great ideas. In fact, AI started in 1959, I believe, in some university, is when. But technology is definitely a big advantage we have today. The second thing is the transformer model you said. Prior to, in fact, even when I got into this space of data analytics and AI, we would take a model and then just completely retrain every bit of that model every single time. In 2017, Google came out with a paper called Attention is All You Need. And all of a sudden, this transformer model made things even more possible, because now it's sort of in an iterative manner, incrementally, we can train bits and pieces. So now we can go a lot faster. So not only do we have GPUs, but now we have a better technique of creating these foundation models, and that's why all of a sudden we see. So in 2017, transformer model came out. Then GPT-2, GPT-3 came out many years ago, actually. But the moment we had ChatGPT, we instantly gave a user interface in which anybody in the local language, mostly English, but I'm not sure about other languages, could ask a question. And that was literally the inflection point where AI became mainstream.
Yes.
So,
Without question. That's exactly right. And I remember when that happened and like, boom, it was like an explosion or something. And I do want to comment, I'll bring Osama in here in 1 second, but one of our regular listeners, a super smart guy who often sends me emails, Alex Husky, he works for XO or Exxon Mobil, I think it is. And he sent me this email that was really compelling. I used it in a webinar with Vertica a couple of weeks ago. He said, we cannot allow these things to pattern recognize their way to the truth, which is very interesting because that's really what they're doing. It's pattern recognition. It's understanding this looks a lot like that, so I'm going to go ahead and put this forward. It's all pattern recognition, but there's no moorings, at least in the LLMs, right? That's why you have vector databases. That's why you train your models on trusted data, because you're giving it these anchors of truth, almost like you try to hold down a hot air balloon with the cords, right? You're trying to hold it down to earth and keep it focused on what's going on here. Not that you'll ever be able to completely eradicate the hallucinations. I don't know, but we're certainly gonna find out. But with that, let's bring in Usama Fayyad. What are your thoughts about all this stuff? And I Sanjeev and I seem to agree this is absolutely transformational. This is not just some evolutionary modification of how we do things. This is going to fundamentally change how we think about software. And frankly, I think these new models are really going to be almost like the new application fabric going forward. But what do you think?
Yeah, I think, well, I agree with some of what's been said. I have a few disagreements here. I mean, we'll start with, so first of all, I mean, you mentioned that it started a long time ago. It's even longer than what you implied, Sanjeev. This whole thing started with perceptrons, which is from the 1940s. Frank Rosenblatt kind of published his first algorithm in 58. In 1958, right after he published that article, there was a New York Times article talking about machines that teach themselves and how they're going to replace our jobs and all of that. So the hype has been around for a very, very, very long time. I think what has been changed recently is kind of, for sure, the compute and the ability to kind of spend huge amounts of money and energy on compute. Let's not forget ChatGPT, GPT-3, which is the predecessor of 3.5 and 4.0. And that was the last time, back in 2000 was the last time OpenAI was open about what it was doing. Had 175 billion parameters in its large language model. The cost of training that on a very limited data set was about $3 million worth of energy just to do the training once. Now, that leads me to a few items I wanted to comment on. I think a lot of the technology today, from a scientific perspective, it's very simplistic. It's really just autocomplete on steroids. All of these models work by guessing the next, not even word, but the next token. So what's the next most likely token to autocomplete what typically starts with a prompt? And the prompt gives a way to restrict kind of those memories and say, hey, do your retrievals or your autocomplete based on what's in this prompt. And the prompts are very limited in size today just because of computational costs and so forth. So I said scientifically not very interesting, although there's a couple of interesting facts. One of them is, how could a model with so many parameters, and remember I said GPT-3 was 175 billion parameters. We think 3.5 is about 500 billion. We think GPT 4.0 is about 1.3 to 1.7 trillion. No one, I guess, outside OpenAI and maybe Microsoft knows. But regardless, trying to train and I'll talk here about what Eric referred to as the secrets. I don't know if I call them dirty secrets. They're not, but they're not talked about a lot. The secrets of making AI work that the companies don't talk about a lot are, and I have a list of 7 of them, but I'll focus on the big 3. The big 3 are: 1, it's continuous need of human intervention and correction. So don't underestimate how much human intervention is happening, both in real time and on a continuous basis, to get these models trained up so that they work. And if you remove the human intervention, which, by the way, our term experiential AI refers to AI with the human in the loop, because we actually recognize how important it is to have the human intervention to correct the AI. And in generative AI, this is especially needed because all these models are knowledge-free. All they can build is a whole bunch of weights or parameters and hope that the autocomplete works. They have no conceptual models. They have no understanding of what they say. The technical term for large language models is stochastic parrots. They are parrots in that they don't understand what they say, and stochastic in that they have a degree of randomness, so they appear to have variation. And we'll get back into kind of hallucinations, or what we prefer calling errors rather than hallucinations. But let me talk about the first secret is huge amount of human intervention is needed. So after the training, for GPT-3, after the $3 million of energy usage is spent, that's not the end. You have to actually put an army of people against the model to do what's called fine-tuning or post-training tuning. And that's where they catch all the weird corner cases and so forth, lots of reinforcement learning, lots of feedback coming from humans. And the reason you need humans is you actually need the common sense reasoning, which no machine today has. No AI has common sense reasoning, so you need the humans for that reason. So that's secret number 1. Secret number 2 has to do with data. So Eric very eloquently said, you need trusted data, well-managed data, truthful data, all of that. What the companies don't talk about is that data set that, say, GPT-3 got trained on. It is not the entire web, as many people try to tell you. In fact, they started with that path, and they quickly realized that doesn't work. The web is filled with contradictory information, bad data, hate speech, all sorts of weird stuff. So they had to go back and do a lot of manual curation. That manual curation is not cheap. This is why OpenAI needed all those billions of dollars of investment, both for the energy and compute infrastructure, as well as the curation of the data, which is a big, big deal, right?
Yeah, and let's pick this up after the break, folks. Don't touch that dial. We'll be right back. You're listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
All right, folks, back here on a very fun DM Radio, kicking off 2024 with a bang. I'm a fan of even-numbered years, so it's going to be a good year. It's a leap year, so we're going to leap forward. Very appropriate metaphorically. But Usama, we cut off in the last segment there, and you were talking about how with ChatGPT, it was not, in fact, trained on just rando content all over the web. They figured out pretty early that's not going to work. We have to be careful about curating this, but go ahead and pick up where you left off.
Yeah, so the cost of curation is extremely expensive. They also went to sources like Wikipedia, which is moderated content. They then thought, hey, scientific articles, people are unlikely to lie or put false facts into scientific articles, so let's use that. So there's a lot of the use leveraging kind of that curation. That's the second secret, which is you gotta curate the data and you gotta very carefully put it together. The third one that is not talked much about, but I suspect will become talked about a lot, has to do with prompts, right? So people are talking about, New York Times had an article about prompt engineering, and people are talking about the new job of prompt engineering. As my colleague, who's a professor at Northeastern and a core member of our faculty at the Institute, Byron Wallace, likes to say, it's not really prompt engineering. It's all more like black magic and weird casts here. The reason he says this is because a small variation in the prompt can give you a completely different result. And this is ignoring the errors and all of that, just changing that prompt a little bit. And people are writing papers now on how adding some weird prefixes to the prompt kind of restrains your attention and gets the LLM to produce a much better answer. And there's a lot of fun and interesting papers to read on this. So that's the third area, which is a huge dependence on prompts, and nobody understands how to do the prompts right. In fact, RAG is one of the attempts to kind of try to control and do some post-prompting to fix the issues by doing lookups. And the lookups are there because they're trying to overcome the bad reconstructions that the autocomplete comes up with, right? So certain tasks where you require a precise answer, like if you're trying to come up with a bibliography, or if you're referring to certain legal cases, you can't just do it from memory. You gotta be very precise. And if you try to do it on an autocomplete basis, you'll actually end up making up things like references and making up things like prior cases, which has happened with that famous lawyer who submitted a very good-looking and eloquent brief to the judge without actually checking the cases that were quoted, and ended up being sanctioned, and some say lost his license. But anyway, the point is that when you use these models, and this is why I don't believe these large language models are going to replace us, they need a lot of human processing after the fact to basically judge, edit, and adjust the output. And that is critical. This is what happens a lot inside the companies, a lot of adjustments and interventions. When it happens, when you use it as a user, it often, that information doesn't get captured. And that's another lost opportunity, which might lead us to discuss private language models versus the public language models. But saying this, hopefully kind of can help demystify how we think about these models. I said scientifically they're not super interesting. There's a couple of interesting scientific facts about them. No one today scientifically understands why a model with so many parameters actually works. Statistics actually has theorems and wisdoms that basically say if you have too many parameters, you will overfit and never learn correctly. And overfitting is a huge problem in statistics. But it turns out as you increase the parameters beyond the zone of where you're overfitting and your performance is going down on the test sets, somehow nobody understands why. Around the millions to billions of parameters, the performance starts coming back. And no one has a scientific understanding of why. Statistics says that should never happen. So that is an interesting scientific fact. But I would say the one thing that's interesting, which is why these models will be with us for a long time to come, is that they hold a huge promise economically. They address many of the tasks in the knowledge economy today. And in the richer countries, the knowledge economy is about 50% of the economy, and in poorer economies, it's somewhere between 19 and 29%, according to the UN. But if you have something that affects half the economy, even a 2% or 1% acceleration can have a huge, profound impact economically. And this is because we created a bunch of jobs in the knowledge economy that are very robotic, very repetitive, very mundane, and that gives a window for a lot of these large language models to do their thing with their autocomplete capabilities and help us accelerate. Now, people are not talking about 1 and 2% acceleration. They're talking about 30 to 50 to 80% acceleration. And that's a whole other area that basically says whether these models are scientifically interesting or not, they are economically very interesting in the context of the knowledge economy.
Yeah, that's all excellent content, Usama. Thank you very much. And I'm going to bring Sanjeev back in, but you reminded me of a very interesting story I encountered. This is analogous in a certain sense. We tried to get to Europe last year for a conference, a very fun event sponsored by Software AG, and I wanted to bring my family, and we needed to get their passports. And post-COVID, going through the passport agency is just not fun at all. Because typically in the old days, and it's still true, but if you had business travel and you could show that you have tickets and all this stuff, then you could get an expedited passport, but you have to go to one of the passport facilities. And it turns out they're all backlogged. Every last one of them is backlogged completely. And of course, this is the US government, so you can't expect the cutting edge in terms of system design. But I figured some things out. So you have to call in and try to get a meeting somewhere. And the closest one here is Buffalo, New York. And then there's DC and Baltimore and lots of other places you can go. And it was incredibly frustrating. You have to go through this whole litany of questions to answer. Do you have travel plans? Yes, I do. What's your city? Blah, blah, blah. Like, there's like 10 questions in a row they ask you. I got to the point, I made 100 phone calls. Okay. I got to the point where I would just read off the list of everything they're going to ask me. And then one guy said, "Oh, I'm sorry. I still have to ask because those are the rules." I'm like, "All right, fine, whatever." And every time you would get to it, you'd be like, "Sorry, there are no appointments," or they would say, "There's an appointment in Buffalo." I'm like, "Okay, great." And then they'd ask you all these other questions. And by the time you answer those questions, that one is gone. So the system doesn't have any sort of lock on it, meaning like once someone's in, someone else can take that from you. So I'm thinking, what is going on here? One young lady, very clever young lady, she says to me on the phone, she goes, "Let me just put in some random characters here." So basically, she tricked the database, the system. She just typed in rando characters instead of what you're supposed to do, which is give it cities and all this other stuff. And it worked like a charm. She goes, "Okay, do you want Seattle, San Francisco, or Vancouver, or whatever?" It's like 3 different cities. I'm like, "What? I'll take San Francisco or Seattle." That's what it was, because of course Vancouver's in Canada. But so anyway, just to your point about one small change in the prompt can give a very different answer that has its origins in traditional queries, because you can sketch out a database with a weird query. And what was it? Mark Madsen once told me that it takes 10 years of a database in production before you're going to find the edge cases that will crash it. So we're still in the early days of understanding these things. And the more you play with them, the more you realize, and here's the last point I'll throw over to Sanjeev, these things have captured a tremendous amount of information. And while it's true that they will make stuff up and have these errors, there is an astonishing amount of detail, scientific detail, language detail, all kinds of things are buried in these systems somewhere. They're trained somewhere they're persisted someplace. So it's going to take a while just to figure out what they already know, which is a ton. But Sanjeev, take it away.
Yeah, thank you so much, Eric. Great example. And just want to build upon what Usama said. The economic value of these new AI models is tremendous. In fact, I've seen they can raise GDP of a country by 7 to 20%. McKinsey has said every year it's like $4+ trillion will be added to the economy, global economy, every year, not just once. So I trust, if not that much, at least there is a lot of value to be added. The problem I want to address is with prompt. So it's so funny how you have to put these secret characters in front of prompt to make it work. I was reading an article just a few days ago because Midjourney, which has been extremely profitable, I don't know if they're profitable, but they're making the good revenue in creating these image outputs. Right. They came out with Midjourney version 6 a few days ago. And the founder of Midjourney was saying that, "Oh, by the way you did prompts in Midjourney version 5 is gone. Don't do it. It'll give bad results." And I'm thinking, wait, you now have to relearn how to even write a prompt? So, for example, what he said was, in Midjourney 5, you could prompt and say, "Create me this image, assuming I'm using a camera called Leica on a 35 millimeter film." And so that hint would then make the output a certain way. And he's like, "No, that's gone." And I was like, this is just like when browsers came out. If you wanted a certain value, you had to put it within quotes and right. with kind of thing. So I guess we are going through the same journey that we went through with a browser. Now we don't even think about it. We just, in fact, Google browser, Google search is so good. It reads my mind and autocorrects my horrible spelling mistakes. So if this is a journey we are on with foundation models, we will get there.
Yeah.
What really I find super interesting is whether it's 175 billion parameters or it's a trillion tokens or what it is, I think we are going to come to a realization where the amount of tokens a model has been trained on is less important than the relevancy of data it's been trained on.
Mm-hmm.
The more tokens is great because I think one of you said the more tokens we have, the model is vastly knowledgeable about grammar and English and all these things, but it's clueless about what my company needs. So what I feel in 2024 we are going to see a lot is happening is that we're going to take these pre-trained models, because why lose all that training that you've done, but then we start fine-tuning it and say, here is my data. So just get intelligent about my data, but you don't have to reinvent the wheel. So take a pre-trained model like Llama 2 and just add this additional information on top.
Yeah, that's a really good point. And, I just thought of another way I can weave children into this in terms of what ChatGPT will reflect back to you. For anyone who has kids, you got to be careful what you say around kids, especially if you trash talk your neighbor or someone they've met or whatever, because they'll just blurt that out when they meet them. Oh, yeah, daddy said that you're lazy or something like that. And it's the same thing with these models, because, again, they've absorbed all kinds of information from all over the place, and we don't know how much information is in there. We don't know. We're going to find out. Usama, I do think it's interesting you pointed out that ChatGPT is no longer open. Now, I guess Llama 2 isn't that the one on Facebook? They came and just released it open source. And it is crazy that you can use these things to mimic behaviors, you can mimic sounds, you can create music that sounds like it's from a certain artist. I mean, there are some pretty intense issues that we're going to have to navigate going through. Sama, what do you think? We got 2 minutes before the next break. Go ahead.
Yeah, I mean, I'm glad Sanjeev mentioned Llama 2 from Meta, because I like the fact not only that it's open source, truly open source, but also they gave an open source commercial license, so you could actually use it to do a business. Up until a certain size, once you hit the billions in revenue, the license stops working. But in general, that's a huge enabler. Now, what it does enable is a very important point, Eric, that maybe we come back to it, which is the ability to create private, smaller models that are narrow and focused on a domain, right, instead of these very large, very broad models that are trying to boil the ocean, that become very, very susceptible to the errors, what Google likes to call hallucinations. They become very expensive to maintain, all of that. So that there's a whole topic of how big should your model be? Can you get away with a much smaller model? And how do you maintain that model and feed it based on your usage? To Sanjeev's point, if your company is using that model and feeding it a lot of feedback that represents your own IP, if you're using a public model, you can't capture that knowledge. If you're using your own private model, you can actually capture it and use it. But that requires a data infrastructure, the ability to capture data, the detailed data you need to capture, all of that.
Yeah, no, that's exactly right. And I think that's the direction that companies are going to go, is you're going to have your private instance. And, I'm sure we'll get better. We'll talk in the next segment about some of these smaller models that are coming out, because, again, we're just on the cusp. We're at the beginning of this journey, and it's already fascinating. And there are remarkable improvements being made, foundational improvements, fine-tuning, all sorts of different things. We've got a great live studio audience today, too, with some good comments in there. So feel free to send your questions that way. Otherwise, we'll be right back. Don't touch that dial. You are listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
All right, folks, back here on DM Radio with a fun, exciting show with Sanjeev Mohan of SanjMo and Usama Fayyad from Northeastern University, the Institute for Experiential AI. Really cool stuff they're working on over there. And that really just means that there's a human in the loop. And yes, you want a human in the loop. Yes, there are unsupervised models. We get it. Someone joked today online, the AGI will be an unsupervised model. I mean, it will to a certain extent, I suppose. But I'm reminding myself that we should get into this interactive AI stuff. And what does that mean? So if you look up the definitions, you'll see on the interwebs, it refers to chatbots, for example, where you're going back and forth with a bot. But there's some other very interesting things that are coming down the pike, and I've heard a little bit about this, but it makes sense if you sit and think about it. I'll tell you that the interactive AI I want, which is to tell Expedia or one of these flight systems, I want to go to San Antonio sometime in June. I don't want to spend $300 round trip, so find me my ticket. And every once in a while, it's just going to wake up and go ping and ping the system and get some answers and ping. And when it finds that information, it's going to go, aha, I got it, boss. Boom, here it is. And it's like your little assistant out there looking for things, waiting for things. And one of the more interesting aspects I've seen about AI, maybe Sanjeev, I'll throw this over to you, is watching again with Google, because they were the first that I saw to start finishing your sentences when you're in Gmail. And they were also doing something interesting where they would surface emails I had not responded to and suggest them and say, hey, do you want to follow up on this? I see that this now in my text messages too. It'll surface something that goes, oh, do you want to respond to this? I think that is going to be the most prevalent way that AI affects the average consumer or the average business person is in suggestions based upon patterns of behavior and weightings, essentially. Because a lot of times it's been correct. I'm like, oh yeah, I haven't followed up with Daryl. I got to do that. I'm like, thanks, computer. That was pretty cool. But Sanjeev, what do you think?
So now I know why you don't respond to my emails. So, Eric, what we are starting to see is there's a lot of emphasis on performance, cost. By the way, someone mentioned what was the cost of training GPT-3. It's just not sustainable. This is like massive energy cost in fact, every time you do ask a question to Chat GPT, that's a very expensive query compared to a Google search. So in this process of reducing the footprint, we are seeing this concept of mixture of experts. These are smaller models, but they're kind of chained together. In fact, chaining has become a very important thing. It's basically the idea is if I want to get to a space where I'm not just asking for summarization, I'm asking for some action to be taken. So I ask, for example, a new person joins a company and they need a lot of onboarding stuff to be done. So can we use these foundation models to have this live English language chat, and then the LLM says, oh, wait, you need to now go do your benefits. Someone send you to Fidelity or Cigna or whatever company it may be. Oh, now once you've done that, now I need to get you to fill up your payroll form, and on it goes. So this actionable piece of AI is the next holy grail. And we're starting to see that where you take a task, divide into subtasks, find a model for each of the subtasks that it's best suited for. For example, I may ask a question in French, but it's an American company, so a translation model kicks in, translates into English, then does. So I see, and this concept that I'm talking about is what we are now calling AI agents. So there's the idea is you ask a question, it goes to a semantic router or a mixture of experts that then determines a plan, just like a query optimizer says.
That's right.
So it's the same idea. Instead of a query, now it's more of a command.
Yeah, no, that's exactly right. And, I was talking to Sanjeev this morning, or maybe a couple of days ago, and Usama this morning, and I'm thinking to myself, in the database world, in like a vertical database, for example, you have these inner joins and outer joins and all these different things that the database does in order to pull information together to feed you the answer that you're looking for. Well, these models don't really care about that stuff. I mean, they've learned about inner joins and outer joins, and they can reflect back to you all sorts of details about how they work and how much they cost and all this stuff. But this is a completely different way of accessing information. right? And again, all this stuff has been persisted in these models. So if you look at the RAG architecture, the whole idea, and I think this is where you want to go, is you want to kind of start with what the moorings say, then go into the GPT, then come back to the moorings again and go, okay, does this look good? And then deliver the answer. There's a company, Kyndi, KYNDI, that has a pretty good solution for this, where they will not only give you this answer, but they will show you where in your documentation they pulled that answer from. That's called a citation, and it's pretty important stuff. That's what you want. But Osama, I'll throw this one over to you. There's an attendee asked a great question about this Mistral 8x7b stuff, saying, what is your opinion about a near future where we have smaller, specialized models that work together? That's exactly what Sanjeev was talking about. And I'm reminded of a show we did with Dan Bodner, the CEO of Verint, a customer experience company, do a lot of really interesting stuff. And they have like 30 bots, he says. And I said, oh, maybe someday they'll do more things than they do now. And he goes, no, it's actually best to have bots do very specific things and do them very, very well. And at the Sanjeev's point, hand it off. So one bot will find the right flight, the other bot will execute the transaction. This is just an example. But the idea is that, yes, you will have, and my buddy Lou Simon from Optima, he built out 5 GPTs in his environment. One is marketing, one is sales, one is admin, one is finance, and he has them hash out business plans together, like talking to each other. So this stuff is possible now, and it's just off the charts crazy. Usama, what do you think?
Yeah, no, I mean, there's no doubt one of the biggest lessons learned throughout the history of AI for the past 70 years is the more narrow the domain, the more narrow the problem, the exponentially higher your chances of success are. So if you can, and that's an art, figuring out how narrow to make it and how small to make it, gives you the ability to solve it very well, all the way down to, the narrower you make it, the more likely it is that you will know everything you need to know about that subdomain, that very narrow domain, and therefore avoid all these corner cases that typically kill you in AI solutions. A great example, I mean, you referred, we are creature, so this autocomplete technology is useful because we are creatures of habit. I mean, back when I was the chief data officer at Yahoo, and we started Yahoo Research, we started with this autocomplete on search, and then Google picked it up as copying from Yahoo, honestly, at the time. But the point is, we discovered very quickly that it became a hugely popular feature because people, guess what? 70% or some, I forget the exact number, of the queries you make are queries you've made before. Same with maps, right? Most of the time you're trying to navigate to a place you've been to before, right? And it's rare that you go somewhere new. One of my most favorite applications of smart technology, I mean, look at how narrow this is. On my Samsung phone, this is like 10 years ago. If somebody tries to call me and I'm in a meeting and I'll say, I'll call you later as an auto response, right? It gives me like 3 or 4 SMSs that I could send as an auto response. I'll say, I'll call you later. Guess what? It actually, 15 minutes later, it pops up a reminder, hey, you said you were going to call so-and-so later, right? And I thought that was extremely useful, right? Talk about somebody who doesn't forget about a follow-up or a promise you made, because I've sent many of these messages and then I get busy and I never call back. So that's an example of kind of being very narrow. And that takes us to the whole mixture of experts domain, which is, can you come up with these very, very, very reliable, very narrow experts and then solve the problem? And this is a problem, it's unsolved. Which expert is kind of the expert that applies on this particular problem that you fed? But that's an easier, I mean, at least now you have a candidate correct answer somewhere in your reservoir, and you just have to let the right expert win in that mixture of experts architecture. That's been around for a long time. We were doing mixture of experts back in the 90s in the NIPS, now the NeurIPS conference. Yeah.
Well, in a way, it's kind of like the ensemble approach, right? If you're working
exactly
in data science, right? It's ensemble. It's a team. You've got a team. You want many eyes to make few the errors. You want many hands to make light the work. That kind of stuff. Well, folks, what a wonderful show we've had here today, talking to Dr. Usama Fayyad. He is the inaugural director of the Institute of Experiential AI. at Northeastern, and Sanjeev Mohan, the legendary SanjMo podcast bonus segment coming up next. You're listening to DM Radio.